All right, I think we can get started. So thank you all for standing by and welcome to today's webinar, Terraform 0.12 Deep Dive on HCL Enhancements and Remote Plan and Apply. My name is Caroline Guo and I am the organizer for this webinar. Throughout the webinar, please feel free to type your questions in the question box. This webinar is going to be recorded, so the recording will be made available within a couple business days, and it will be sent out to everyone who's registered. So our speakers today are Arslan Syed, Senior Solutions Engineer from HashiCorp, and Kristen Lambert, Software Engineer with the Terraform Engineering team. Please feel free to reach out to either of them directly via Twitter or LinkedIn and for any follow-up questions. And now I want to pass it off to Arslan to kick us off and get started.
Thanks, Caroline. All right, so we're here today to talk about Terraform 0.12 and some of the enhancements, and also remote plan and apply. As Caroline said, my name is Arslan Syed. I am a solutions engineer here at HashiCorp for about 8 months now. Prior to this, I was at Thomson Reuters, and I worked a lot in infrastructure, the non-Terraform way. So being here, I've definitely learned quite a lot and learned to appreciate quite a bit of what our team's been working on. And the team has been extremely busy in the last year to get this specific release out the door as well. And we're pretty excited for the release sometime next year for our GA release. So there are 3 main goals for our talk today. And we'll basically cover the introduction to Terraform, right? We'll go a little bit into infrastructure as code, workflow of open source and enterprise, and talk about a little bit about the providers. The second thing is, we're going to Terraform 0.12. We'll look at the HCL enhancements, and Kristen will go through some of those enhancements. Given the amount of time that we have, we can't cover all of them in depth, but she will show you some pretty cool stuff. I'll get into, right after that, I'll get into the remote plan and apply, and we'll get into Terraform Enterprise at the end to kind of give you guys an understanding of what Terraform Enterprise is, what the differences are, and that'll also lead into the demo for remote plan and apply, and it'll kind of show you guys some of Terraform Enterprise as well. So, as we all know, we've come a long way in terms of provisioning infrastructure in the last couple of decades. So again, we're going to look quickly into Terraform and get you to Kristen as soon as possible so you can hear some of that cool HCL stuff. So HashiCorp has a set of products in different areas, right? We have the product called Terraform, which is an operations product, a product called Vault, which is a security product, Nomad, which is for development, and then we have a product called Console, which is in the networking space and provides you service mesh capabilities. But essentially, we provide you applications to help with the entire application delivery lifecycle. The talk today is specifically about Terraform, and we'll get into in depth about Terraform a little bit more. So let's just move on. So now the shift that we're seeing in terms of infrastructure, right, is this manual, single data center or on-prem data centers, right, where we have a lot of manual provisioning and all of that. And we're seeing that shift going from the static infrastructure into a dynamic infrastructure where we have multiple clouds, we have multiple data centers, and we're not just we're working a lot more with ephemeral services, so short-lived services. Things are coming up and going, so that makes it extremely challenging, right? So if you kind of look at provisioning in the dynamic infrastructure world, right? Previously, there was, like I said, there's a lot of manual provisioning. You had a fixed set of resources that you really had. Workflows required ticketing and queues. The process was extremely difficult at times, right? And the way Terraform approaches this is basically with infrastructure as code, right? If you're not familiar with infrastructure as code, it's essentially a way to codify your infrastructure into a text file, and you basically tell Terraform what it is that you want or what type of infrastructure you want, and Terraform will go out and actually go do that work for you. You don't have to worry about the how. So about the Terraform principles, we have a few principles. I think there's 7 or 8. I'm only going to cover 3. These principles are pretty important. I think that we do follow them, for all of our applications, and it's called the Tao of HashiCorp. And at the core, Terraform is basically infrastructure as code tool, right? It provides you with one workflow to provision any infrastructure on any cloud. And it does that because you have the capabilities of infrastructure as code. It simplifies that process quite a bit. The second principle is workflows, not technologies. So, instead of worrying about the underlying technologies, which can change, from time to time, from year to year, from day to day, we focus more on the workflows themselves, right? The workflows that you need in order to provision this infrastructure in this new world. And then the last bit here is, open and extensible. So, Terraform has over 160 different providers. So there's cloud providers, there are the major cloud providers, we have the other cloud providers, we have other types of providers like Datadog and DNS Simple. But these providers make this process a lot more simpler because Terraform has a core that does a lot of different things, but we separated out the providers so that you can get day zero support for some of the services that are coming out almost every single day, it feels like, right? So that's kind of how we keep up to date, is that by separating these providers out, allowing the people, whoever are managing those providers, and in the cloud case, right, many of the cloud providers are also already updating the Terraform providers, on their own, right? So they're keeping up with it. They work with us very closely. We're partnered very closely with them. So, again, this really helps in keeping the providers up to date at all times. So how does it work, right? Terraform, there's a lot possible in Terraform, right? If we look at the enterprise workflow a little bit, right? We'll look at it more in depth a little later. But Terraform is going to provide you the ability to provision any infrastructure on any cloud, but it can do that in a couple of different ways, right? And depending on your, the customer's current workflow, they have a few options. First option would be, you have your operators going into some sort of GUI, and they can create workspaces, do a bunch of things, but it's all GUI based, right? The second option is you can have some sort of config, Terraform config. You load that into version control, and that version control, like for example GitHub, GitHub can be tied back to Terraform Enterprise with a callback address. So whenever you make a change into your code, you can actually trigger a plan within Terraform to make sure that everything is all right. And then the last bit here is, being able to work within the CLI. So, that's kind of what we're going to get into at the end with the remote plan apply. So I won't get into that too much right now. But that's the other option, right? Where you have, the CLI that can now interact with Terraform Enterprise by changing, small lines of code, and now you can reap the benefits of Terraform Enterprise. Previously, this was a challenge to customers. So looking quickly at some of the use cases, Terraform, like I said, provides you infrastructure as code. It is one of the core things that allows us to do all the things that we do. You have the capability for multi-cloud management. So instead of having to learn all of the different cloud services and how they do it, whether it's YAML or JSON, you don't really have to worry about that anymore. Terraform gives you that one workflow. We have our language called HCL, which is HashiCorp configuration language, and that will allow you to work with all these different cloud providers and other providers in a similar fashion, right? So everything looks and feels the same, even though the APIs might be different and the requirements for creating an EC2 instance might be different from an Azure VM, but that workflow remains the same. And that makes the process extremely simple. The last bit here is a self-service infrastructure. So, giving the ability to your organization to have that capability of self-service infrastructure. And we'll get into this a little bit more, so I won't get into this too much now. But we'll talk about, our producer-consumer model as well, which helps organizations share all of the work that they're doing, right? They can create things like modules, and they can create reusable code for their infrastructure. So not everyone has to go in and start writing code. They can, have the developers, write some code, and the application users can actually, leverage that without having to write too much. So now we're gonna get into Terraform 0.12. So I'm gonna hand it over to Kristen. So here you go, Kristen. Pass this over to you.
All right, thank you, Arsen. Sorry for that delay there. Got a little distracted answering questions in chat. Okay, so as you know, I'm Kristen, and I'm going to be talking about Terraform 0.12 and specifically some of the HCL enhancements. So for those of you, and I think most of you have used Terraform before, you know that Terraform is really the tool for defining infrastructure as code. And even since it was released, it's a really cool and awesome tool. But early on, our users found even cooler ways to use it to make Terraform do complicated things. You did really neat things with modules, and you started coming up on edge cases in the configuration language when we really just couldn't quite support what people needed to do. And we saw what people were doing and loved it, but we knew that the underlying configuration language needed enhancements. And from the questions, a lot of you already know we need those too. So I'm going to do a quick overview of HCL, and then we can look into some of the specific enhancements. Now in Terraform version 0.11 and earlier, when I'm talking about the configuration language, it's made up of 3 components. HCL is the HashiCorp configuration language, and this gives us our block syntax and attribute syntax. HIL is the string interpolation language, HashiCorp interpolation language, that lets us embed expressions into HCL strings. And that's where you're going to be used to seeing the $, curly brackets wrapped in quotations notation, plus some Terraform native variables and functions. Terraform 0.12 is going to introduce HCL2, which is a complete rewrite of that underlying configuration language. It merges HCL and HIL, introduces a robust type system, and really lets us address a large list of feature requests and enhancements. And pretty much any enhancement we didn't get to in this release, we've set the stage by switching to HCL2. Now, I'm going to be covering a couple of key HCL2 enhancements, but there are more than I'm going to be able to talk about today. So this is just a short list. Even this is still not a complete list of the enhancements. And there'll be a link later in the slides to the Terraform blog posts that go into greater depth in the HCL2 enhancements that are coming. So I highly recommend you look into it because I'm barely going to be scratching the surface. And I'm going to do that. Okay. So the first thing I'm going to talk about is first-class expressions. Expressions are native to HCL2 and they can be used directly. And when I say that, what I mean is you no longer will need to wrap everything in the quotation $, curly bracket, which I really wish I had a shorter way of saying. But the fact that it takes forever to say, I feel like is important. And also lists and maps, which are an expression, can be used directly. So I don't need to use, as this example here shows, a function to create an empty list. I can just use the empty brackets. Okay, so this doesn't make a great slide explanation. So let's look at some examples. Now, in my slides, I'm going to be showing several examples that switch between an HCL and an HCL2 syntax. I will always say which we're looking at, but you can also look right at the slide and it will say Terraform 0.11 or 0.12. So 0.12 is the new HCL syntax. So I have here a very simple and somewhat contrived example. This is just a main.tf file that is creating an AWS instance, and we are passing that instance a security group ID. So the key things to look at, I've got my variable security group IDs, which is declared to be a list, and then I've got my resource. So I'm going to show you the same thing in HCL2 syntax. Okay, we've got several changes highlighted here. First of all, in the variable, you'll see that I'm declaring that is type list with a type of string. We'll look into that in more detail in the next section, rich value types, but you can also see that list is no longer wrapped in quotations. Likewise, the variables, so var.ami, var.instance type, so on, are not wrapped in the quotation, curly bracket, $, not in that order syntax. Excuse Linus. Okay. So here's a slightly more complicated example back to Terraform 0.11 syntax. The difference I want to show you here is that I've changed the variable VPC security group IDs to a string, and then I've added a conditional statement that says, and this is the bottom of the screen, if VPC security group ID is not empty, shove that variable into a list and pass it in, else use this list function to pass an empty list. So it's a somewhat hard to read syntax, which of course I'm showing you so we can compare it to HCL2 0.12 syntax. Okay, here's just back to my security group IDs is defaulting to empty, but now if you look at the conditional statement, it's a lot easier to read. Same intent is if security group ID is blank, is not blank, use that, but otherwise we can now just directly reference an empty list. So this may look like a little change if you've not written a lot of Terraform code, but for someone who's written thousands of lines, this is actually a really exciting simplification and a lot easier, in my opinion, to read and reason about. Okay, so that's first class expressions. Now I want to take a look at our rich value types, which I think is probably one of the most exciting features, definitely has the most value for module writers and people who have kind of large, complicated code bases. So while HCL has supported lists and maps since Terraform 0.7, HCL2 provides a rich type system that supports complex values, things like maps of lists and lists of maps. You can define your types explicitly, and you can also use entire resources and modules as values to pass around. So let's take a look at what that looks like. Now, my next couple of examples, I'm going to be bouncing between a main.tf file and a module. So I just wanted to share kind of an example module layout if you haven't written a Terraform module before. All I have is a simple main TF file and a TFRs file in the top level of the directory. And then there's a subdirectory called modules, and underneath that, a module called subnets with a file dot there. So just setting the stage. I'm going to pause just for a second so you don't have to listen to me take a drink of water. Okay, thank you. So here's my Terraform 0.11 main.tf, which is using a subnets module that I was just talking about. We're passing it a single variable networks, and then I'm using output from the module to output the VPC ID. Okay, so this is very basic, and we'll see the same thing in 0.12. We will see the same thing. There we go. Okay. Oh, no, I'm sorry. This is the subnets.tf submodule in 0.11. Apologies. So here's that submodule. It's also fairly simple. We're just creating an AWS VPC using the network variable that was passed from main.tf, and I'm outputting two values, VPC ID and the VPC availability zone. So if you've written modules, you know that the only attributes you can use in your top level main.tf has to be output from the module. Okay, so now I want to take a look at the same thing in Terraform 0.12. So this is my main.tf, and the first thing I want to show you is that I'm here declaring networks as a very complex variable. It's a map with mixed type values. Other than that, this main.tf is pretty much the same as the first one we saw. So we're going to jump down into the subnets module. No, we're totally not. I should really mark what my next slide is. I wanted to show an example of actually defining that variable now with the complex type. So as you can see, I'm defining two different networks, production and staging. I've got integers in there, so they've got a network number, and strings for the availability zone. So just wanted to kind of show off how cool that looks. Now we'll look at the subnets TF. Here, again, we've got the same networks variable. We've got the same resource, not exciting. What I want to draw your attention to here is actually the bottom, this output VPC. I am outputting the entire value of the AWS VPC that is being created in this module. So if you recall from a couple slides ago, if I needed to have access to an attribute, I had to explicitly output it. I output the VPC ID, and then I output the VPC availability zone. But thanks to HCL2, I'm able to output the entire resource, which means the top level main.tf has access to all of these attributes. Okay, and so here's kind of back to our main.tf, where I'm showing a somewhat more realistic example of why this is exciting. I am using the output from the VPC to create an AWS instance. As a module writer, I don't want to have to go back and refactor my module every time a user needs a different attribute out of the module. So now I just know that no matter what attribute out of the AWS VPC you need, it's available because I've output the whole VPC. Okay, the last topic I'm covering is improved error messages. And I used to have this whole spiel about how nobody but me is excited in improved error messages, except I opened the slide at HashiCorp and got applause. So apparently everyone's excited about error messages. So I just hope this excitement continues. If you've written really any amount of Terraform code, you've run across cryptic error messages that really just didn't tell you anything helpful. You may have spent errors tracking down a bizarre message to have it turn out to be a syntax error, or you get a syntax error like the one I'm showing on my screen here from Terraform 0.11 that gives you no real information. If my main.tf is thousands of lines long, and it very well could be, I'm going to have a very hard time finding this error. I have myself spent hours of my life commenting out entire files just to uncomment them one block at a time to figure out where the error is. This is very annoying. We're all annoyed when we have to do this. So in Terraform 0.12, you'll find that the HCL parser is really helping us give you more clear, concise, informative errors. The parser retains detailed information about the location of tokens and syntax elements. So when you get an error, it will refer to specific source files and locations. And it can also even share the identifying header that that location is within. So when you look at this example here of a Terraform 0.12 error, I'm shown not only that my error is in the main.tf file, it's giving me the line number it's on, and as you can see here, the error is that I don't know how to exit Vim properly, and giving me a specific summary of the area. Argument or block definition is required here. Okay. In this next example, you can see that it's printing out, again, the entire offending line. So the error here, it's going to show me the file name, main.tf, line number, what output it's in. So this says in output foobar, so I can find exactly the block of code. It's also printing out the offending lines. So you can see here, it may not be obvious, but I'm trying to add a number in a string, and it is unsurprisingly unhappy about this. And so it's giving me a good summary of the error. It's an unsuitable value, a number is required. Makes sense. And then the final one I want to show. Okay, so here we have a bit of a typo. I wrote output-ui when I wanted to write output. And I've got in the error message, blocks is not expected here. Did you mean output? So we've got a really exciting number of enhancements to error messages. And while you'll see these changes in 0.12, we are continuing to iterate and improve upon them. So what you see in 0.12 still isn't final. There's a lot that we'll be working on building. Now, as I said, this was a very brief summary, but there's a lot of enhancements, and I could have gone in much greater depth for even the few I spoke with. So I really do recommend you go find our blog posts. Our writers are phenomenal. They're really good to read, and they give a lot of code examples. And there's also, I think I'm going to show you up with one more slide with some good examples of using HCL2 features. Upgrading your code to work with Terraform 0.12 should be very straightforward. 0.12 will be released with a config upgrade tool. I'm not positive what the CLI command will be named, but it'll be effectively Terraform upgrade or maybe Terraform 0.12 upgrade. This will run through your config files, automatically make any edits required, and print out a summary of changes you may need to go make manually. So most of the changes that people will have to run across will be simple syntax formatting changes that are largely aesthetic. Some things you will find is that certain words are now reserved words that you may not expect, like count is going to be a reserved word. So if you have variables named count, you're going to have to need to give them more descriptive names. But we do have an upgrade guide on our webpage, and it is being continuously updated. It's a work in progress guide. So as we finish wrapping up 0.12 release cycle, that will get updated. Okay, now we'll be passing this back to Arslan. So
thanks, Kristen. All right, let me try to do this again. Just making sure you see my screen, Kristen. All right, cool. All right, so we're going to continue and talk about the next, features here for remote plan and apply. If you haven't heard about remote plan and apply, it's essentially tying in the open source to your Terraform Enterprise. Previously, this was slightly a challenge in that, it wasn't just, you modify a little bit of code and all of a sudden you're using all of TFE and get all the benefits of the runs and state and all of that. But let's go into this a little bit. And the first thing I want to talk about, since this is a Terraform Enterprise story or a workflow, we have to look at the Terraform Enterprise workflow, right, a little bit deeper. And I love this slide because it shows that pretty simply, right? I talked a little bit about the producer and consumer model. So the producer and consumer, we're going to look at the producer model first, and then we'll look at the consumer model. But basically, if you look at this, you have this version control system in the center, right? That could be GitHub, GitLab, whatever it may be. And then you have your policy owners that update these policies, and they get applied into Sentinel. So Sentinel is a feature of Terraform. We'll look at that a little bit later. But it's basically like guardrails around your infrastructure. You can check for different things like are people provisioning in the right time of day in the business hours? Are they provisioning certain instance types or anything like that? We'll look at that as well. And then you have your infrastructure operators. We're going to create your modules, right? And we have something called a private module registry. We also have a public module registry. But when you get our enterprise version, you get a private module registry, and what that does is allow you to store all these modules centrally in a way where you can have other teams go in and build these modules and stack them together with some configurations, right? It's a pretty simple process, and I can maybe show you that if we have some time. And then you build out resources, right? So your network workspaces. So now you have network workspaces here. This is just one example where you have a network workspace for production, staging, and development. And basically, you have the ability to create these for, network, for storage, for EC2 instances. And this kind of becomes your best practice in your organization, right? And you have your, operators and your teams kind of working on creating, the core of all of this. And then what happens is when your application developers, when they're looking to create their applications, right, they don't have to build everything from scratch. So if your network team has defined what a VPC looks like, right, and this is the best practices for our VPC, then what you can do is you can just pull from that those different modules and those different workspaces, and the application developers can create their own workspaces using those, right? So that means you're kind of pushing your best standards to these application workspaces, and they don't have to worry about that anymore. And the modules are also versioned, so it's not like you're gonna have breaking changes. You can select specific modules and things like that as well. So the next bit here is, as we know, or most of you will know, is that Terraform has a concept of plan and apply, and Sentinel fits right in between, and we'll look at that a little bit later. And then Terraform also has a TFE API, right? And then you can use VSTS or Jenkins or GitLab, and you can communicate with TFE directly via the API. And then Terraform is going to allow you to provision any infrastructure on any cloud. So looking quickly at the Terraform Enterprise UI, right? Just a couple of things to note when we get into the UI. On top you see the workspaces. One thing to note is, you have multiple workspaces here, right? And that's kind of our recommendation, is that you'll have multiple workspaces, say, for networking, and they'll all be tied to the same exact repo on the back end. So instead of having multiple, branches or different type of code everywhere for different environments, you can tie into one specific repo and then make those individual changes for those environments in the individual workspaces themselves, right? So environment-specific variables and things like that. And then the state will also be managed separately as well in this case. And then you have your runs history. We'll look at that as well, but you have a history of all the runs. You have the ability to put in some variables, and then you have state management, and then you have a bunch of other settings. And again, we'll kind of look at this a little bit later, so I don't want to waste too much time here. And let's get into the demo. I'm going to pause this for a second, get set up just for 1 second, so you guys just see my screen again. All right, so the way I've built this demo out, my hope was to kind of show you some of those, features of Terraform Enterprise in the process, but also show you how to set all of this up, right? So the first thing we're going to do, let's just get things set up, right? So the first thing I want to do here is I want to show you this real quick. I want to filter by backend because the new workspace that I'm going to create is going to be called backend. At the moment, there's nothing called backend here. And I'll go to my EC2 or my AWS console, and I'll look for TFE underscore backend and see if you guys see that there. Make sure you can see it. It's still there because I created it right before I got onto this webinar. It'll be gone shortly, but you can see that it's terminated. So there's no EC2 instance online at the moment for TFE backend, right? So we're set up with that. Let's go back into the CLI now. The first thing I'll do is just make sure Terraform is working, which it is. I'll look at the Terraform version, and I'm using the Alpha 4. Clear that out. And then what I want to do is, so I'm in my home directory, and I have a couple of files here, and I'll go through what some of these are shortly. But basically, what we're looking at here is the RPA example demo. So what I'm going to do is I'm going to copy this demo into another folder, right, called RPA demo. And then we're going to go into RPA demo and look at the files that are in here. I've kept this as simple as possible to make sure it keeps working and the demo gods stay with me, because they were and they weren't for a little while. But let's look at the main.tf. It's pretty simple, right? You're creating one EC2 instance. We're using the AWS provider in the US East region, East 1. Again, a couple of tags, nothing crazy here. So I'm creating it just for anyone who doesn't know or isn't familiar. You have AWS instance here. I'm naming that instance. I'm using the specific AMI, and I'm using T2 micro in this example, and then these are the tags that are here. So what I'll do is I'm going to edit this. I'll hit I to edit. And then I'm going to add in that block of code that I need to put in for the remote backend. So I'll get in here, and I'll go up and add that right at the beginning. This could be in a separate file, but you can just put this right here, just like that. So you have a remote backend set up. My organization is called Arslan Hashi, so I'll go back here just to kind of show you guys. I have an organization called Arslan Hashi. There's a couple of others. And then my host name is app.terraform.io. I'm using the SaaS version, so that's what I'm putting here. If you had a private Terraform install, you'd replace this with the host name for that private install. I'm selecting a specific workspace here called backend dev, and you'll kind of see that process shortly. So then I'll hit escape. Do this, hit escape, colon, I'll write this, quit, and I'm back here, right? So now what I'll do is I'm going to do a quick Terraform init. Right, now that I have the backend in there, it's going to try to connect. And you're going to see this failure, right? I did this intentionally. But what I want to do is I want to show you that you have to set these credential file. And let's go back to my home directory, and I have this example. So I'm going to go into VI example. I don't know why it's not coming up. Example underscore Terraform RC. And this is not a real token, but you see exactly how it looks. It's in the guides as well. But that's basically what you need, and it needs to be placed in the home directory. For Windows, it's a little bit different. The guide kind of gives you an example of that. I'll escape out of here. So now what I'm going to do is, since I don't have it where it needs to be, I have this tfrc.real file, which is my real one, and I'm not going to show you guys that one, but I'm going to copy that into Terraform RC. And now what I'll do is I'll go back into my RPA demo. RPA demo. And now I'm back to that main file, and I'll do a Terraform in it again, and you'll see that demo guys are not with me. Hang on one second. Terraform. Oh, I didn't create it for some reason, so I'll create it again. So I'll copy my tfrc.real to .terraform rc ls-a. Okay, that's there now. So I'll go back into cd rpa _ demo, and I'll do a Terraform init. Terraform init. And now you can see it initialize. Hang on one second, guys. I'm gonna pause this just to make sure I have my right token in there. Everything was working just before this. Hang on one second, guys. Demo gods are not on my side. Okay, let's do this. Terraform --a. Okay, I think I got it. I keep writing Terraform for some reason. I'm trying to type fast. So let's do that again, one more time. So I'll copy my Terraform RC real to .terraform RC. All right, now I'm here. All right, so we'll go back into cd rpa _ demo, and then I'll do a Terraform init, and that should work. Terraform init. There it goes. All right, so now that will successfully connect and initialize, right? And you can see on the right-hand side that it actually created the workspace. I'm not going to be able to do much with this right now because I don't have any of my variables set, right? So there's no state, there's no runs, none of that stuff. There's no variables in here, nothing. So what I'm going to do now is add some variables, and I'm not going to show you guys my stuff, but I have another CLI open. And what I'm going to do is I'm going to use the TFE CLI, right, which is a pretty simple way of adding variables to your Terraform environment. So what I'm going to do is, and you'll see this just in a second. Right now, there's nothing there. So I just added my AWS access key. Then I've added my secret access key. Give it a second. And I've added secure variables, right? So now I'm going to refresh this. Refresh at some point. Okay, so I have my variables here. So now I can do some other cool stuff, right? So now once that's set up, and just one thing to show you guys, one pretty cool thing with Terraform Enterprise is that you can mark these sensitive variables. So I've uploaded the variable, but I've marked it as sensitive. And now no one can ever see this. So if you wanted to overwrite this, you could do that, and you can kind of mess things up for other people for fun. But it's pretty cool that we have Vault under the covers that secures these variables for you, and you don't really have to worry about how it does that. But it just takes care of all that, for you, and make sure that no one can see those variables. So then what I'll do is, okay, I'm going to go back, and I'm going to do a Terraform plan. Terraform plan. And this might take a couple of seconds, but I want you to see, I'm going to go to the queue here. If I go here and I go to my queue, so it's popped up already. And if I click into this, you can see that now, the Terraform run has gone through Terraform Enterprise. It's not running locally. And just give it a second and you'll see this pop up on the left-hand side and the right. It's going a little bit slow. Not sure exactly why, but it's waiting for a queued run. Let's make sure there's nothing else that's queued. I've had this happen before, but it starts moving along pretty quickly. Let's go to runs. Backend. Go back in -dev. Yeah, I had this happen before. Don't know why it happens. I'm going to follow up with the team a little bit later. This happened to me a few times, but I'm going to cancel this. And what I'm going to do is I'm going to do a Terraform apply instead. It'll actually go through the plan as well. Maybe because I'm using the alpha, maybe not. I'm not sure exactly what the issue is. Then let's go here. There it goes. So now you'll see this come up, and you can see that it did the plan, and you can see there's one to add. Everything is kind of side by side. You can see it happening in the CLI. You can see it happening on Terraform Enterprise. The cool thing is that now it's going to do a policy check, right? And it's going to fail. And the reason it's going to fail is because I have my policy set where it is going to fail. So I'll show you guys why it failed real quick. So let me go to my settings. You have a bunch of settings in Terraform in the organization. You have teams, you have your VCS providers, you have various tokens and things like that. But policies is basically your sentinel. And I'm going to look at this one. It's a pretty easy to understand example. Right now, I have it as hard mandatory. So that means that if anyone does not check out of this policy, then they basically will be denied to provision any infrastructure, right? And the reason it failed is because I've only allowed these instance types, right? And I'm using micro, I believe. So what I'm going to do is I'm going to go in here, go to advisory, update this policy. And now what I'll do is I'll run that again. So I'll do another Terraform apply. And I'll go through that process again. Make sure it's updated. And now this time you'll see that it actually goes through. Back in that dev. So it's running a little bit slow. Hopefully it speeds up a little bit. I know we have a couple of more minutes left. Definitely works. It's just running a little bit slow right now for some reason. Go. Let's see if there's anything else queued. Making sure there's nothing else here. Yeah, maybe what I could do is go in here. I can cancel this one. I can cancel this run. Maybe it'll trigger. There it goes. So now I triggered. I'm gonna go back here. I don't have much left for the demo, so just go through this real quick. So I went through the plan. It's gonna do the policy check. It's gonna pass that policy check, and then it's gonna go right into the apply, and then it's gonna ask me for approval. So then I go into here. I hit yes in my CLI. So it passed the policy. You can see that now, and now it's gonna actually go in and apply that infrastructure, similar to how it's done on the open source version as well. And that is almost done. And then if you go in here, I mean, just to kind of do a fact, quick proof here, Giphy underscore backend. You should see another one pop up here. There it is, and it's pending. So it will be provisioned. To take my word for it. I don't want to waste too much time here. I know we have a lot of questions to answer. But just to kind of recap, right? I mean, the last bit here that I wanted to do is kind of do a Terraform destroy. What you have to do is you have to go into similar how it is in the cloud, where you have to like retype the name of the resource in order to delete it. You kind of have to do the same thing here. It's a little different. But you have something called confirm destroy. You go into your variables, into your environment variables, you add that in, and then you add that in, but with a value of 1, and then you save that. And then now I can actually destroy this. If I did it before I did that, it wouldn't have worked. Now if I do a Terraform destroy, it'll actually go out and destroy all of these resources, so we're not paying for them. And that's basically the demo. Only other things to mention is to kind of recap as to why we're even doing this, right? I mean, number one, it helps you preserve the core workflow. So if you're already using the CLI, you don't really have to change much, as you can see here, right? You're gonna have the state being managed directly through Terraform. So now you have all these different states, and you can click into the state and you can see all the different states within here. You don't have to manage that. You don't have to worry about locking or none of that stuff. You have access to all of your different runs. You have access to set the different variables for your different workspaces, for all your different environments. So there's a lot of features that you get just right off the bat without having to really change much on your workflow, right? The other thing is to be able to securely store your secrets, right? And then non-public infrastructure access, where you may have some VMware vSphere installations, right, that aren't really publicly accessible. Terraform might have access to it, but other people cannot access that infrastructure. So you can use this workflow to keep Terraform with access to VMware, but your application users or developers, they don't really need that access to those credentials and things like that. And then obviously you get the history, you get the policies, you get approvals, you get RBAC. So there's a lot of other features that you get by going into Terraform Enterprise. So I'll kind of kill the demo here. I hope you guys enjoyed this, and we'll kind of open it up to questions.
Thank you, Arslan. Yeah, so I think that Kristen's been going through some of the questions and answering them throughout the webinar, but we did pull in some that have been asked pretty consistently, so I did want to ask it out loud so some of the folks in the audience can hear them and you guys can have a chance to answer them. It looks like there's a lot of questions about compatibility and upgrades, so wanted to pose the question around, will 0.12 be backwards compatible with 0.11?
Okay, so that's a really common question. I'm sorry I didn't address it when I was talking. So the idea is to maintain backwards compatibility, but as I did mention for things like count being a reserved word, so there's some changes you may need to make to your Terraform code for your 0.11 compatible code to run against 0.12. So basically, the intent is they're going to be very, very minor syntax changes, and otherwise you don't need to go and do a bunch of rewriting. So we're trying to maintain as much backwards compatibility as possible. I know that's not the same thing. It's not exactly a yes, and it's not exactly a no. So we're aiming for yes, but there may be some minor changes you need to make. One of the problems we've run across just in going from HCL to HCL2 is there are some features that have only accidentally been working because of, I kind of heard it referred to as sloppiness in how HCL2, it's kind of permissive in what it allows. And so since it's now a strict type system, there are some things that will have to be fixed.
Great. Is there any commentary, Kristen, you can add on when Terraform 0.12 will be available?
Yes, we're, and I know some people have already been joking that our blogs have said for quite a while at the end of the summer, and it is well past the end of summer. So our goal now is the end of February. That's what we've been saying for the release. We'll be aiming to have a beta out. So the alpha is available now, first of all. If you're the kind of person who wants to go and mess around and look at what fascinating things are working and what other fascinating things are broken, you can go download the alpha from releases.hashicorp.com. We're going to get a beta out early next year, and so you should have anywhere from 2 to 4 weeks with the beta available before the general release.
Great. There's also a couple other questions about providers, and I can answer that one. So there's some questions about the Kubernetes replica sets and GCP as well, and so I think those providers are going to be coming out very soon, so stay tuned for those. There's a couple questions in here about the availability for remote operations is Terraform Remote State available for open source within 0.12 release?
Remote state, I believe it is available, but I would like to kind of check in on that. I don't know which release that's actually going to be of, which release is going to be a part of, but we can kind of follow up. I'm not sure if anybody else in the group knows. Hey, Megan.
Hi. Yeah. So Terraform 0.12 has the capability to enable remote state in the open source version. However, to take advantage of it through Terraform Enterprise, you need Terraform Enterprise. So you can't actually do it with just the open source version.
Got it. I knew that. I don't think I understood the question well.
No, that's okay. Thank you. Okay, I think we have time for one more question. Let's see here. Okay, do we have roadmap for 0.12 attached to provider release as well? How will it affect each other?
This I can answer.
Yeah.
So all the providers will be re-released with a major version bump to be compatible with 0.12. For provider developers, we're again trying to make this as little effort needed on their part. It's simply a matter of upgrading the SDK. So we're trying to do all the work for the provider upgrade in Terraform core. So provider developers hopefully won't have to do a lot for the upgrade, but it will require a version bump.
Okay, great. There was a couple questions about the Terraform free tier and when that's going to be coming out. Although we didn't talk about it so much on this webinar, we have a general GA plan of halfway through 2019, but we don't have an actual date for that as of yet.
Also, I see a bunch of questions, people asking about some of the other new enhancements to HCL. So I have that slide. I know we didn't share it because I think it was hidden. I'll just share that real quick so they can see. And if they want to go through some of these demos, hang on one second. You see my screen?
Yes.
Yep. So Roger Berland, he's a colleague of mine. He's another SE. He basically, kind of came up with all like a guide for all the examples. So the ones that we didn't cover, you can kind of go through here. I created a bit.ly for it to make it a little easier to get to. But this is public now. It's a part of our Terraform guides. And you can go there and you can learn about splat operators. I saw somebody asking about that. So you can go here and you can kind of dig in a little bit more and get some more information.
Okay, I think that wraps it up with the questions. If any folks in the audience want to reach out to any of the speakers directly, their information will be included in the follow-up email. And again, you can reach out to Kristen on Twitter and then Arslan likely on LinkedIn. So thank you all again for joining. Overall, some great questions from the audience. I hope everyone enjoyed today's webinar and have a better understanding of Terraform 0.12. I've also added a poll at the end of this webinar. So once I launch it, if the folks in the audience could take a second or two to just reply and provide some feedback. And finally, as I mentioned in the beginning, the webinar is recorded and it will be made available and it will be sent out within 2 to 3 business days. Thank you, everyone.
Thank you. Bye.